Hi, this is Max from GAGE Motorsports with a episode of how to get the correct rocker geometry. GAGE Motorsports in Meriden, Connecticut. Our phone number is 702-845-7181. Please give us a call anytime if you have any questions about any of our products. And today we're going to be talking about, again, the proper geometry for the gauge roller rockers. So to start with, we want to talk about push rods. This area here shows two different style push rods. The style push rod with the smaller neck is what is necessary to use the gauge roller rockers. This type of push rod requires the sheet metal type rocker arms, but it also requires the pushrod guide. With the gauge roller rockers and the correct pushrod, which is this guy here, the guides are no longer necessary. So first I want to talk about the ratio of the rocker and how you can inadvertently change the ratio by misadjusting the lash screw. Now the ratio is created using this fixed number, which is a dimension from the center of the trunnion to the center of the roller. In the GX200, that happens to be 0.906. And to get, in this particular case, I'm using a 1.3 rocker geometry here, which means the distance from the center of the trunnion to the center of the ball on the push rod needs to be 0.697. That gives you a full 1.3 ratio. Now, if your push rod is too short, and you have to run this screw down. You see this piece of geometry here? If you run the screw down to this level, which is about 5 turns of the screw, that'll bring you down another 204 thousandths. So if your push rod is 204 thousandths too short, this lash adjusting screw is going to end up down here someplace. And when you do that and take a measurement from the center of the trunnion to the center of the ball, you end up with 0.727 instead of 0.697. And when you calculate the ratio, that actually works out to a 1.246 ratio instead of a 1.3. So adjusting the lash and using the correct length push rod is key to this. Now, how do you know how short or how long your push rod is? Well, the gauge rockers are designed so that if the bottom of the screw is flush with the bottom of the rocker, it's about correct. Actually, it's actually designed to stick out one thread. So if your lash screw is flush with the bottom of the rocker to about one, maybe 1.5 turns sticking out the bottom, then you have approximately the right push rod length. The difference is going to be minimal as far as the ratio goes, but the perfect ratio, 1.3, the screw should be sticking out about one turn, one complete 360-degree revolution of the lash screw. So how do you know how much too short your push rod is or how much too long your push rod is? The way we would do that is to mount your rockers, use the current push rods that you have, adjust your lash, but don't tighten the 12-point nut. Then you can take the rockers off and see if the screws are sticking out. Let's say they're sticking out. You can take an Allen wrench now and count the number of turns that you have to rotate the lash screw until it's about flush or sticking out one thread. Each turn is 41 thousandths, and that's what this here is. So about 5 turns at 41 thousandths per turn works out to 204 thousandths. Actually, probably closer to 205 thousandths, so that dimension may not be exactly correct. But again, if you're sticking out 5 turns, you're down to 1.24 ratio, maybe 1.25. So that changes your ratio and definitely affects your performance. Not to mention, if the screw is down that far, your chances of popping a push rod out is pretty significant. You'll probably end up losing that push rod. It'll pop out, get caught on something, bend, and you'll be a disappointed racer that day. So now we've covered the type of push rod we need, and we've covered the way you can inadvertently change the ratio of a rocker. So let's scroll down here and let's talk about how to adjust the stanchion. Now the stanchion is what holds the trunnion up. There's 2 bolts that go through that and mount to the head. And this section here, these 3 lines here, represent the stanchion, and it kind of sits around the trunnion. There's a radius cut into the stanchion that the trunnion sits in. So this is a diagram of the movement of a rocker using a 400 thousandths lift cam. Now every cam is a little bit different, duration's a little bit different, how the ramp works is a little bit different on each cam. So we're going to talk about how to use this process on various cams, but I just chose a 400 thousandths lift cam for the purposes of this demonstration. If you look at our valve, the valve stem ends here when the rocker is at full closure of the valve, and we'll call that 0 lift, and that's where, and I'm going to zoom in on this, that's where the roller actually makes contact with the valve stem, or if you're using a lash cap. Alright, this line here is the center line of the valve stem, and should be the center line of the entire valve, including the ground surface. So if we started off with the roller touching the valve stem, and if we zoom in on this, you're going to see it's going to be touching the valve stem right at the point of the center of the valve stem, and that's where the roller actually makes contact. But if you look at what happens when this roller rocker starts to move, and this circle here represents the arc that is going to travel as it depresses the valve. At half lift, or 200 thousandths lift, this line here being the center line of the valve stem, and this line here being this contact point, you'll see that it moved forward of center by 15 thousandths. And as the rocker continues on its journey down to 400 thousandths, which is where we are here, the contact point now is 15 thousandths behind center. And that happens when you have the correct stanchion height. Now the way I can check this very quickly on an actual engine is to take some black magic marker and just mark up the top of the valve stem or the lash cap. Put your rockers on, put your push rods in, set your lash, and then manually run the engine through a couple of revolutions. And what will happen is you'll end up with a little wear mark right in the black magic marker. You can look at that wear mark. Does it look like it's in the center of the valve stem or the lash cap? And if you're very close to the center, and your eye can actually see, if you're 10 thousandths off or 20 thousandths off, your eye can probably see 10 thousandths if you have a decent eye. Because the stem is so small, a slight misalignment will show up very quickly in that black magic marker. But if you're approximately in the center of that valve stem, you're good to go. But let's say you're on the back side, meaning this side here of the valve stem. So what do? The way to change the location of that wear mark is to change the height of the stanchion, which holds up the trunnion. Now, if you use a taller trunnion, let's say you shim this, and if you do shim, you have to shim both sides equally, and when I say equally, within 2/1000ths of an inch. So if you're going to put washers underneath the stanchion, you want to use a micrometer to measure both of those spacers to make sure they're within 1 or 2/1000ths of an inch of each other. I think the maximum this will tolerate is about 3/1000ths of an inch. So now what happens if you raise, let's say you shim the stanchion, what does that do to the wear mark? Well, what it's going to do is it's going to move the wear mark closer to the rear, this being the rear. So it'll actually move that wear mark over in this direction. If you machine the bottom of the stanchion off, and if you do that, make sure you machine exactly the same amount off of both, what you'll do is you'll move the wear mark closer toward the front of the stem in this direction here. And when you measure the stanchion, you don't measure the stanchion for the overall height. You measure the stanchion from the bottom surface to the very bottom of the arc, which is this area here, because this arc is actually machined into the stanchion. So you want to measure from the bottom of this arc to the bottom of the stanchion and make sure both stanchions are identical if you machine anything off of those stanchions. Now, once you have this height correct and your wear mark correct, now you go back in, put your push rods in, set your lash, and then see where the screw ends up. And then you can start counting your screws. And I'm going to go back up to here and repeat what I said earlier. You can start counting the turns on the screw until the bottom of the screw is flush to sticking out one thread. When you count those number of turns, and let's say it's 2.5 turns. If each turn is 41 thousandths, 2 turns would be 82 thousandths, and another half a turn would be another 20 thousandths approximately. So you're talking about 102 thousandths is what you need to make the current push rod longer, by that much longer. So whatever that old push rod measures, add the 102 thousandths to it, and then have push rod made for that side exactly that length, and then you'll be right on the money as far as getting the correct geometry for your rocker. Now, a lot of people just use the same size push rods on both sides. That may or may not be a good idea. If you have one valve that, let's say you recut the seat and now it's sticking out another 10 or 20 thousandths, you're going to need a different push rod length for the other side. So it's always good to mark your push rods, exhaust and intake, because each side may not be the same. They could probably be within 20 or 30 thousandths of each other and we're okay. If one side is flush and the other side is sticking out one thread, you're still good to go, because at that, being that close to flush is not going to make a real big difference in your ratio. So anyway, that covers how to get the correct rocker geometry in using the roller rockers for any engine. It's not just the GX200. The same applies for all the other engines, regardless of what size they are or how many cylinders they are. And the same goes for a V8 engine or a straight 6 or a V6. Whatever engine you're using, this is the proper way to set up a roller rocker system, or even a sheet metal rocker system for that matter. Anyway, that concludes today's workshop. And I just want to remind everyone, if you have any more questions, just give us a call at 702-845-7181. That is my personal cell phone, and I always answer that unless I'm already on the phone. So I'll answer that 24 hours a day, but please let me sleep. Again, thank you for watching, and we'll catch you next time.